Number 24 for 6.5.
So 24, a p squared?
Yeah, plus 8.
So guys, the first thing to notice about this problem is, can I get p by itself? Is there any way to get p truly by itself?
No,
I could subtract p squared and 7, but then I still have p on both sides, right? I can't really just try to solve for this p. It doesn't give me a number answer. So that's the whole point. If that wasn't there, we could solve for p. If I see a power higher than 1 on something, that tells me to do what? What do I need to do to try to solve this? Factor, there you go. Because I had this whole idea, if I have a number times a number equals 0, then what's got to be true about one of those numbers?
0.
It's got to equal 0. I like the hat, by the way. Go someplace. It'll overcome that first one. So that's why we factor, because if I factor this and get two little pieces that multiply to be 0, I know one of the pieces, one or the other one, has to equal 0. So it's kind of a trade-off. We take one ugly problem and we make it into two nice little problems. Is really what effectively happens. So this sometimes is a little bit difficult when you have a problem like this. There's no real way to factor 7 except the simplest way, 1 and 7, and 1 and 7 make
just
8. Cool. So whenever that last number is 1 off from the middle number, more than likely there's going to be 1 in that number. Don't worry. So then it would be what now? P plus 7. And then you can say what's got to be true.
P equals -7.
P plus 7 is 0. Or P plus 1 is 0.
Do you want us to write that part, or can we just say P equals -7?
Yeah, you don't have to write that part. Sometimes you might want to if it's a little more complicated in there.
Yeah.
So then you'll get -7 or -1. You can write it like that. If you really want to, you can write it like this. There's probably some teachers before me that have made a big deal out of putting, I don't know. It's nothing special about that. You can just write this and that's fine. How we doing? Does everybody kind of get this step here? This step is a little weird because I'm not doing algebra from here to here. I'm applying a concept. There's no math I did from this to this. I said, oh, these two multiply by 0, so that's 0 or that's 0.
So it's not -7 for the answer? Or it's just
Oh, yes, sir. -7. Thank you. All right. So the things you have to look out for are when they don't start off equal to 0. And to be a little mean to my math 281 students today, I had to kind of come down on them this morning because they did really bad on the last test. And one of the reasons they did bad was because they had a problem like this. To be fair, it wasn't exactly like this, but it was close enough to make me very worried. And guess what they did? Some of them, not all of them. They said either x minus 4 is -18 or x plus 7 is -18. And then they went from there. What mistake did they make? The only time you can use that.
Factor it back out? No?
What's the matter with this? It's not. It is. But what's got to be here in order to actually use this property? It's got to be 0 there. Because how many things multiply to be -18? A lot. More than 3 and 6 and 2 and 9. What about 36 and 1/2? A lot more than we realize. You with me? So there's an infinite number of things that could multiply. Oh, that's just too many things to worry about. I want to cut down on the number of things it could be. I want to make that equal 0, so then I know that 1 equals 0 or the other one equals 0. That's the only time I know something for sure. So you sure as all hell cannot say this. Because if that's -18, then that has to be 1. So you have to somehow solve both of those, and if it doesn't work, you'd have to try 3 and 6, and if that doesn't work, you have to try 2 and 9. If that doesn't work, you have to try 36 and 1/2, and no. Yeah.
So to make it 0, you would just add 18 to both sides?
I love it.
Okay.
Yeah.
Before I do that, though, I make room for the 18.
Okay.
There's nowhere for the 18 to go.
That's what I was
I've got to re-multiply this out. X squared,
7x
good, plus 7x, minus 4x, minus 28. Now there's a place for this to go. I can put these together.
Negative 10.
10.
Yeah, they're opposite sides, so negative 10, yes. And now this you could factor, and that's the right time to factor because now it's equal to 0. Cool. So be real careful. It's obvious. I'm not necessarily trying to show you how crazy my Math 281 students are. I'm trying to show you how easy it is to make this mistake. Even somebody up in Math 281 can make that mistake because you just kind of focused on going. You're like, crap, I can't do anything unless that's equal to 0. I got to re-multiply, suck it over there, make it, factor it again. Okay. How are we doing? So a few of these things are not going to have equal 0 on that side. You've got to bring it back over.
I see that you did the like term, but would you ever just leave it as 4 terms and do grouping?
I'm not guaranteed that this grouping will work because this number is brand new now.
Okay.
It has nothing to do with this and this anymore directly.
So I think there was one on the homework where I did the like terms, or no, I tried to group it and it didn't work.
Yeah, the grouping almost, I would put money on it not working.
Okay.
Because it'll work 0.01% of the time,
Okay.
which is not good odds, right? I wouldn't put my money on a lot because I don't have a lot of money. But I would put money on that it wouldn't work. How do you factor this one? X and X?
X minus 2.
Good. 5 and 2, which one's positive?
5.
The 5, the bigger one to make that plus. So then X is, see if you guys can see it. Negative 5. Negative 5 plus 5 is 0. Or X is positive 2, because that would make that 0. If you don't like that, you can certainly still say X plus 5 equals 0, or X minus 2 is 0, and then solve. But some people pointed out when it's like this, you should be able to look at it and say, what would you subtract minus 2 from to make 0? Well, 2. And you can see that right here. You'd add 2 over, and that's what you get. You get positive 2. Cool. Okay, maybe. How are we doing there?
Okay.
That was our first example of, at least mathematically, where we need to know how to factor. We could not solve this equation. We could not solve this equation if we didn't know how to factor. Okay. Any other questions from home? Yeah.
Question 40
Same one? All right.
on page 398.
This is let me show you something kind of nifty with this one. What's the first step on this problem and why?
It's a 20 minus 25 on the other side.
Yeah, so you would do what to both sides?
Plus
Add 25. Why are you doing that?
Maybe 0.
Because of what? Because that's the section we're in. Because of this here, right? The higher power? If that wasn't there, I would just divide by 60. I'd be done, wouldn't I? So it's because there's an x with a higher power on it than 1. I can't put these x's together, so there's no way to get x by itself directly. So then I add that 25 over. Now, there's something specific about this problem that saves us from having to do 36 times 25 for that tremendous number. Nothing will come out. Shit. So we're stuck with these big numbers. But what's special about 36 and 25? So I'm going to try it. If it doesn't work, then I have to go 36 times 25. But what I'm going to try is this. 36, 6 and 6. 25, 5 and 5. How do I check to see if that's true? I currently have no idea if that's true. So don't finish the problem out before you make sure. I know I'm going to get this because I put the 6x and the 6x. So I know that's there. 5 and 5 is 25. So the only thing I still have to check out is 60x. And sure enough, I get 30, and 30 is 60. So what kind of problem can you do that on when the first number and the last number are perfect squares? You can try to do that. Very often it will work, especially in this book. They like to give you that kind of problem. So if I saw an 81 there and 49 there, I try 9 and 7, 9 and 7, and then see with the middle term if it's true. You guys kind of with me?
Mm-hmm.
If that doesn't work, then you have to do this times that and do, oh God. But let me try the easy way first. If that doesn't work, crap, maybe it's harder. What's the last step here now?
One of them has to equal 0.
Yeah, either this one is 0
But
or that one is 0. What's funny about this?
they're the same thing.
I like it. So you don't have to solve one, really, right? Who remembers, though, so you'll get subtract 5, divide by 6. You'll get that guy there. But how many answers did I say there should be? If it's a second degree, there should be 2 answers, and there are. They just happen to be the same. For this guy and this guy, I get this answer. So there's like 2 of the same answer here. Okay, maybe. Okay, cool. Maybe.
Mm-hmm.
So obviously that's going to work whenever you get these perfect square types things, whereas this times itself. So of course you're really just going to get one answer. Well, we actually call it repeated answers. So there are 2 answers, they just happen to be the same thing repeated. Any other questions from homework? Dave, I think you've been waiting.
60.
$60 is kind of funny because some people are going to do the wrong first step. It's equal to 0, right? You definitely do not want to start multiplying this out. That's the opposite of what you want to do. Yeah?
What's right next to 6x squared?
It's trying to be a plus. Sorry. It's all right. So the thing to realize, this is an evil problem because they did the first step for you. But when we see this problem, our brains are so used to, oh, distribute. No, the whole point when it's equal to 0 is to try to factor it, right? So this guy's been factored already. I still have to try to factor this guy. And what are the steps involved in trying to factor this guy? Yeah, 6 times negative 12, negative 72. I need factors of negative 72 that make 1. There you go. Some of you guys are realizing, if they're opposite signs and they make 1, they have to be 1 apart. Like 6 and 7. Here, 8 and 9 work beautifully. 8 and 9 multiplied by 72. Which one's got to be positive?
8.
The bigger one has to be positive, yeah. So what do I do with these 2 numbers now?
Plus 9.
Can you rewrite the middle?
So that's got to be negative. So it'll be 6x squared plus 9x minus 8x. You break up the middle term so you make it 4 terms. But do you start to see, obviously, if you have any trouble with factoring, these are obviously going to be difficult because the main step is factoring. And then you got these dinky little equations to solve. If you can't factor, you can't get to the dinky little equations. So pretty cool with this so far? I mean, we knew to multiply these because that's a 6. It's not a 1. So I'm going to take it into account. Negative 8 and 9 make negative 72. When you multiply, they make 1 when you add them. And I break that middle term apart so I can do the grouping step. Yes, sir? You're good? Okay.
Yeah.
All right.
Because it's the same 9.
Yeah, 9 minus 8.
9, yeah.
X, 9x minus 8x makes 1x.
Yeah.
So on one level, it's kind of silly. You're like, all right, great, Jeff. 9 minus 8 is 1. Way to go, buddy. But I could have put 7 minus 6. The problem with 7 and 6 is the grouping won't work. There's a million things that I could subtract to make 1. A million minus 999,999. Screw that. What's going to make the factoring work, the grouping work, is the numbers I find by doing this. Those are the only numbers that will make the grouping work. So then this guy is just sitting out here waiting. He's already done. What comes out of these two? 3x, good. 2x plus 3. Good, 4. Since you took a negative out, they both become plus. This guy just comes for the ride.
3x minus 4.
Good, 3x minus 4.
2x plus 3.
2x plus 3. And I don't care how many you have in a row, if it equals 0, one of them's got to be 0. Either it's the first one, or the middle one, or the last one. Cool. So either x plus 1 is 0, or 3x minus 4 is 0, or 2x plus 3 is 0. Now notice something. If you were to multiply this out, can anyone tell me what the highest power would be on the x? If you were to multiply this out?
3.
Yeah, third power, right? X times x squared is x cubed. So I should have 3 answers. How many answers are we going to get? Kick ass, right? It's possible 2 of them could have been the same thing. So you could say, well, we got 2 answers. And I would say, no, one of them was repeated. So we got 3. Right? But if you have a third degree, you should get 3 answers. Okay, now, just to be fair, has anybody ever heard of complex numbers? Imaginary numbers? If you've never heard of it, you're like, all right, see, I knew they were just making this shit up. You could have, we're going to get the real answers. When you learn complex numbers, there might be some complex answers, which we ain't going to get, because we don't even know how to get them yet. You with me? So if you just get one answer and it was a cube, it's because the other 2, we don't know how to get them yet. They're what's called imaginary complex numbers. Okay, hopefully we're good. So here I'm going to get negative 1. Here, after a little bit of work, I get 4/3. And there, divide by 2, I get negative 3/2. Cool. Okay. So the main idea here is get it equal to 0 if it isn't, if the power on the x is going to be higher than 1, and then factor. So the only reason you would multiply this out is if somebody didn't make it equal to 0. Then you have to remultiply and bring it over. That's the only time you would multiply something out. Any other questions?
18.
And that's this guy here?
Yes.
So this is another one. They've done the work already. So don't multiply through. They've already factored this, right? This is something times something, and it equals 0 already. So what step am I at? What can I say now? If I have this times this is 0, we can say either the first thing is 0, so the w equals 0, or 4w plus 1 equals 0. And that's a difficult problem because we're not sure what the hell to do with that. But we just, w equals 0. Hey, I'm done. W equals 0 is an answer. Sweet. Or 4w plus 1. Okay, I got to solve that one. So whenever there's a letter sitting there by itself, it's going to be an automatic 0 answer. Because if you set that equal to 0, you're done. There's no solving to do. It's w equals 0. I know that's going to make it 0. Okay. And what do you do with this guy? Yeah, subtract 1. And then divide by 4. Negative 1/4.
So whenever it's something times something equals 0, is that like the end of the problem? And
That's the almost end of the problem. That's why
Well-
those are actually kind of weird, because they're almost done.
Okay.
Like, there's got to be more to it. No, it's already been factored. You just take each piece equal to 0
Okay.
and solve. Cool. Here, this hasn't been finished yet. That's why there's so much more work. But the minute I get something times something times something, I can set each one equal to 0. Go to 10.
Okay.
This is the section where when students learn this, you set everything in the world equal to 0, which personally is kind of depressing. Everything in the world doesn't equal 0. So what I mean is, you'll see, I'll say simplify this, and somebody will tell me x is 0 or x is -7. I didn't say this isn't an equation. What do you think you should do if I say simplify this? What should you do? Exactly. Simplify means do the operations, multiply. Simplify is actually the opposite of factor. Factor says undo the multiplication. Simplify says do the operations. So to simplify this, you would just say 4x squared plus 28x. It's not equal to 0. You can't just suddenly make everything equal to 0. That would so suck. Unless your bank account is negative, then equal to 0 would actually be better. But no, in general, I don't want to do that. Okay. Any other questions from? Okay. A few more questions, we'd probably be done with this section. Okay.
Next, 58.
Oh, that one is 58 is almost exactly like this one. You see that?
Oh,
The first guy, you leave him alone. The second guy is not factored yet.
I don't think we have to do 58
That's okay.
on.
You do whatever one he wants. But that, you do it exactly the same way. Just factor that big dude, and then when you get here, you set each factor equal to 0. Okay, cool. All right, so we're going to get back into chapter 7.
I have one more.
Yeah.
70.
I like 70. Do you guys notice something about both sides of this?
Yeah, x plus 3.
Yeah, they both have an x plus 3. Can anybody figure out why we are definitely not allowed to divide by x plus 3? What could x be?
Anything.
Anything. So it could be -3, just to come out with something. Wouldn't -3 make this 0? So if you divide by x plus 3, could you be dividing by 0? Yes. So you pretty much, in an equation, you can really never divide by a variable. Unless you say in the beginning, well, x can't be -3. Now let me do it. You kind of with me here? Now, so I can't just divide this away, because it could be losing an answer. And in fact, in this case, you would be losing an answer. Do I want to distribute this stuff through? Because what do I want to do eventually? I want to have what here?
0.
0. And then what do I want to do the stuff that's over here?
Factor.
Factor it. If I just pull this over the way it is now, isn't there going to be something common to both that I can pull out? That would be a factoring step, right? So it would still work if you multiply this out, bring it over. It would still work. It'd just be a little longer than it has to be. It would still work. But I would suggest that you leave this alone. You subtract this business over. Now, if you don't like what I'm doing, you can certainly still distribute. It'll still work. It'll just take a little bit longer. What can I take out of here and here? X plus 3. And then what's left? 2x minus 3x plus 1.
But if there's 2 x plus 3s, You're only taking one out?
Because there's only one. How many p's are here? How many p's have I written? You know where I'm going with this, don't you? What do you get when you multiply it in? Do you have two p's? No, you have one that was distributed to two things.
Okay.
Cool? So that's why if I go backwards, if I take that out, there's only one of them. That, if I wanted to check, I could distribute it to two things still, right?
Yeah.
Okay. That's why it's not this or something interesting, right?
Mm-hmm.
There's not two of them, there's just one of them. And in here I can clean this up a little bit, right? Wouldn't this be x plus 3? What can I do with this negative? Bring that through. So what do I get in there? Yeah, I get negative x minus 1, and now what can I do?
Distribute.
What is it equal to?
0.
And how many things do I have over here multiplying? A
Is that
couple.
when you add the, or subtract the 3 and then add the 1? Or only, you would bring it down and x equals negative 3 because it's...
Yeah, that's the idea. Yeah. Why am I allowed to do that? Because it's something times something is 0. So either this is 0 or this is 0. And then solve those. Cool. So this would be negative 3. This one,
Okay.
you finally get negative 1. Okay. Maybe. Y'all look very excited about this. But just realize the main idea here is to factor. So very often, sometimes I won't want to multiply it out, especially if there's a common factor, because I can factor that out of the way. And then my factoring is done. Now, like I said earlier, if you wanted to do this problem this way, there's nothing wrong with this. Multiply this out. Multiply this out. And then subtract to make it equal to 0. I'll tell you honestly, in this case, this is actually a little quicker. But go on. Because I end up with, see here? Over on this side, I end up with 0. What do I get here?
X squared.
X squared
It's 4x.
plus 4x
Plus 3.
plus 3. And that's easy to factor. But can you see how we got a little lucky there? That there was a 3 and a negative 2, so I ended up with a 1x squared.
Mm-hmm.
Okay. So you could do this problem either this way, or you could go ahead and multiply everything out so you can pull it over and get your like terms together. You know you want to make this equal to 0 because of the fact that there's these x squares running around. So if you multiply it all out, you can get your like terms together and then factor whatever's still there. This way ends up to be a little bit quicker just because we were lucky and we got a 1 here. How do you factor this now? The only way to do 3 and 1. So you get x equals
Negative 3.
-3 or x equals
Negative 1.
-1. Same thing we got there.
That one's a lot less work.
Oh yeah, in this case. But if that would have been like a 6 there or something, then you would have had to do the surefire, which would have been a few more steps. So it's, either way you like to do it. Okay. So those were some examples of some extreme problems. The classic problem you're going to get would be, something more like what's going to work, Jeff? Like that. So what would be the steps here?
Subtract n minus 8 from both sides. Or no.
Subtract m.
And then add 8.
Add 8.
Oh.
Of course, you're doing that because there's a higher power on one of the m's. There's a square. You want to get it equal to 0, and then try to factor what you get on that side. So if I pull everything over this way, I'm leaving 0 there. A big mistake people make is they don't put anything there. Like that whole side just suddenly doesn't exist. 0 exists. 0 is a thing, so let it be 0. And what do I get on this side? I get
Subtract, or minus 6m plus 8.
cool. And now what do you do with this?
Factor.
Factor it. I love it. The whole thing that's driving my choice of what to do is the fact that there's a square there. I can't get those m's together, so I got to pull everything to one side and then try to factor things. If that wasn't there, ain't no way I would do that crap. I would subtract my m, divide by the and get it done. Just get m by itself. Right? That's chapter 2. Plus, when you get a higher power in the m, I can't do that. I can't get my m's together. So we had to come up with a new way to do this. And how do you factor this here?
M minus 4. M minus 2.
So then m equals
Positive 4.
positive 4 or
Positive 2.
positive 2. I love it. Because we're just thinking to ourselves, what would make this 0? 4. What would make this 0? 2. Or if you did set these equal to 0, you would add 4, so it would be positive 4. Whatever way makes sense. Or actually write the little equations out. Whatever makes it work. Cool. I can't stress to you, obviously, even my math 281. A lot of times I think that you guys in here, well, one thing I think you think sometimes is that all of math is like this, and that's not true. The rest of math uses this. And there's a good example. My math 281 students made a simple mistake here, a mistake based on a process you guys are learning right now. So it never goes away. It's just used for more complicated problems. So now, let's get back into chapter 7. So I'm going to do a little bit of lecture, and then I'll let you guys do a few problems on your own, just to let me shut up for a little bit. Listen to me speak. It's a little old, I understand. But I do want to explain how some of this stuff works. So last time we did an example that started off too easy, some of us might think, but it really illustrates the idea. Variables are just numbers I don't know yet. So I really want you guys to hear this. Variables have to do everything that numbers can do because that's what they are. They're numbers I don't know yet. So the whole last chapter was really focused on learning how to factor. We first multiplied and then we factored it because numbers can be factored. Things with variables should be able to be factored somehow too. Some of them are prime, just like numbers, but some of them you sure enough can break them up. So if I can reduce ratios of numbers, there probably are some variable stuff that I could reduce. Because again, variables are just numbers. They have to be able to do the same things. How do you reduce this? Exactly, because 10 is 5 times 2. 15 is 5 times 3. The 5's go away. What do you mean with that? Would any of you ever do this? 10 over 10 plus 5. The 10's go away. What mistake did I make right there? There's a 10 on the top and a 10 on the bottom. How is that a mistake? I like it. It's not multiplication. How could that division bar cancel this addition? It can't do that. Division can't cancel something in addition, right? But it's so easy for us to make this mistake the minute I start putting letters in there because we're like, that's not the same as numbers. They can do whatever the hell they want to. Or we get hopeful. So if I had something like this here, what do you think your first step is?
X times X. Oh, wait.
Factor it out. So the bottom I can't do anything with. It's just an X. But the top, what can come out?
X.
X. So I have an X times
X plus Y.
over X. And now the only operations I have are this times this divided by this, therefore the division can do its job.
So it's just x plus y?
Yeah. How are we doing so far? Is that
So
okay?
you knew to factor because of x is squared?
Because it's the only way I could do anything. Really. The only way I could do anything with this is to factor and see if something will be common that I can cancel.
Okay,
Cool.
makes sense.
I like it. So here, you guys try this one. So you gotta catch yourself. Part of your brain is gonna want to do more than you're allowed to do. You gotta tell yourself. The first step is to factor anything that isn't currently factored before I try to cancel anything. So what can you do on the top there? M squared comes out. Good. And what's left? And the bottom is already factored, right?
Yeah.
Don't multiply that back in. That's going backwards. You want to try everything to break apart so you can see what pieces might cancel. So in the bottom, I just leave it as m times n minus 4. Now, what exactly cancels?
M minus 4.
An n minus 4 cancels.
And then
And an M on the bottom.
And one m cancels.
Oh, really?
Right? Isn't that m squared over m? Can't I cancel an m out?
Yeah.
Same thing as 9 divided by 3.
Is that like when you go m times, and then on the bottom it's m times m? And
If you wanted to.
Is that like that?
Oh, another way is it just properties of exponents, right? When you subtract 2 minus 1 is 1, so you have 1 left on the top there. So the only thing left is m. Everything else canceled. Yes, ma'am.
So if the M was left on the bottom, you
It'd
would
be
end
1
up
over it.
flipping it or something?
Mm-mm.
No.
It would just be 1 over m.
Oh.
Yeah, so, I mean, if we had, you know, if we had m squared over m cubed, that's just 1 over m. Because 2 m's cancel with 1 left on the bottom.
Yeah.
Cool.
Okay.
All right, try this one. So, real quick, what form is the top in?
It's already factored, or it's already,
Cubes, right? Yeah.
yeah.
So what do you have to do? The
Big to little bit.
little do big dude. I love it.
Oh. Mm.
right? X cubed is x, x, x. 8 is 2 times 2 times 2. So what goes in the little dude?
X minus 2.
Good. 1x minus 1, 2.
X squared.
Good. The other two x's go there.
Plus.
Plus, good. 2x plus 4, the other two 2's. Now on the bottom, don't do too much.
Take 4 out.
Take 4 out.
The middle term is the little dudes together, right?
Yeah, that's this times this.
And I forget why the middle term is positive.
He's got to be the cancellation term, so he's got to be the opposite sign.
Okay.
Yes, ma'am.
Can you take out a 4x out of the bottom?
16
Does the
have an
16 have an x?
No, no.
Okay. Whenever you see, by the way, whenever you see a cubes in any of these kind of problems in section 7.1 or 7.2, be really careful about any 3-term deals you see, because what do you get left with here when you take a 4 out?
The top. Well, the.
I get left with the big dude.
Yeah.
I don't know if you guys remember this. What can you never do with the big dude of a cubes? That's a very strange sentence. You probably wouldn't hear it anywhere else except here. What can you never do with the big dude left over from a cubes? You can't factor him. So don't waste time. You can never factor the big dude. So in these problems, if you see a cube somewhere and you see some other trinomial you're having trouble with, they might be the same. That might be the big dude from there. Then they'll cancel. Because what cancels here?
The big dude.
The big dude. I'm left with x minus 2 over 4. Can I do anything else here?
The 2 and the 4.
You can definitely not do that. Because again, can division cancel part of the subtraction problem? No, that's more than the operation can do. Division can only cancel out part of a multiplication problem. You with me?
Okay.
You can never break into an addition or subtraction problem.
So it wouldn't ever be x minus 1/2 or something?
Definitely not. And there's another reason why it can't be this. Because what's being divided by 4? The x and the 2. So how the x escape being divided by 4 somehow if you do that? No good. The x can't escape it. It's got to be divided by 4 somehow. Okay, how are we doing so far?
Good.
Decently well? All right, so obviously I don't have to make the point over and over again. If you can't factor, you're going to not be able to do this because that's step 1. Okay, so they can continue just throwing more and more forms of factoring in there, right? Surefire and grouping and all that kind of stuff. All you do is you look at the top as a factoring problem, you look at the bottom as a factoring problem, then you step back and you go, okay, what's the same? What can I kill? Right? Very violent. Old school. Can somebody tell me the smart thing to do with this first? Yes. You can reduce it because, exactly. And you can't cancel out this way, of course. But anything that's on the top that has something in common with something on the bottom can definitely reduce. You with me? You definitely don't cross multiply here. All right? That's the opposite of what that's saying. So 4 goes into 4 once, it goes into 16 4 times. 9 goes into 9 once, it goes into 27 3 times. So you end up with 3/4, 11. So if I can do it with numbers, I should also be able to do this with variables. So really section 7.2, that's what we're getting into here. I'm kind of sneaking our way in there because 7.2 is the same thing as 7.1. It just has more. So you'll see a problem like this. So this is section 7.2. You'll see a problem like this. Like what, Jeff? I don't know.
So would you factor them first, right? That.
Yeah. You've believed that math people just love to throw as much into one problem as we can, and now it's been justified. So 7.2 is all about, it's more than that though, we're obviously not just done, but this could actually happen. Just like it could actually happen here. So you can have these two rational expressions. They're ratios of expressions, so we just call them rational expressions, multiplying each other. So somebody heard the first step in these kind of problems is always factor first. Ask questions over here. And then kill what you can. So you look at this as 4 factoring problems, right? Which would be the worst nightmare of somebody who can't factor, obviously. So this is why I can't stress enough that if you're still having trouble factoring, you have got to come see me. Or at least a tutor. You've got to get some help because you're not going to be able to do any of this. So you take each piece of it one at a time, right? What can you do with this up here?
X minus 4, X plus 1.
Yeah, that's what I call a thank God problem, right? Little difference of squares. So x minus 4, x plus 4. What can you do at the bottom here?
X.
This is one of the easiest ones to make a mistake on for some reason. It's not 3 terms, so don't try to do that. You always try what first?
Oh, the greatest
GCF.
common factor?
See, that's so easy. When we see that x squared minus 4, we try to do it immediately 2 parentheses.
Yeah.
It's not going to work that way. Yeah, exactly. And what's left? All right, keep going. We already see something that's going to go out, right?
Yeah.
Yeah.
What happens up here?
X.
X squared
X plus
and X plus.
X plus 5, X plus.
I like it. 4 and 5 make 20, 4 and 5 make 9. Right? So now you just go to town. And this is the part where the messy amongst us will hate. Because it's all about keeping track of who's still alive. Right? So if you're really messy, you're going to miss some things. And I am one of the really messy people. So when I do a problem like this, I've got to be extra careful to show myself who's still alive. What do I mean by that? I mean, what's going to die here?
6 minus
X minus 4.
X minus 4.
What's going to die up here?
X plus 5.
And then everybody else cross cancel?
Oh, I didn't do that part. The X plus 1.
Yeah, the x plus 4s go out.
Oh, okay.
super X.
And then 1x cancels with 1x there. So what's the only thing left alive?
An X.
X. Cool.
That's not what I.
All of
Okay.
them.
Now to me, I always hear that. I always hear somebody say, after all that work, that's all I get. But to me, it's like, after all that work, I made all that shit become X. I mean, that's nice. That's the way to look at it. You did all that work to make it look a hell of a lot better. All of this is the same as X. That's what that's saying. So would you want to work with this? No, I'd much rather work with that. Thanks.
I know, right? Can't we just start out with just it equals X?
In the real world, I'd love it if we could start with the solution too. I agree with you. But this is actually pretty honest. In the real world, we have a mess that we try to simplify as much as we can. So that's in the real world, we get this stuff, and we try to simplify it down to this thing.
What would the x equal then? X equal 1 or?
I'm with you. Is this an equation?
No.
So you're not going to get an answer for X. This is a simplification problem, yeah. So there's no equation, is there? Okay. Don't worry, those are coming up. Yay. Okay. That might mean. All right, yeah, just to let you know, I'm not going to do this, but if you let X equal like 9, you could figure out what these are as numbers, and if you worked it out, you would get the answer 9. You see what I'm saying? So if you let X equal 9, this would be 9 squared minus 16. Why did I let it be 9? Oh well. If you let X equal 5. If X equals 5, I guess I'll do this. You'll get 5 squared minus 16, and that's why I was 9. I was thinking ahead. 25 minus 16 is 9. 25 minus 20, is that cool? If X is 5, isn't that 25 minus 20? That's 5. This will be 125 plus 125. We do that again. 5 cubed is 125. 5 times 5 squared is 5 cubed again. That's 125. So that'll be 250. 5 squared is 25 plus 45 is 70 plus
I
20
can never be a math teacher.
is 90. How are we doing? Even if you didn't quite follow all my calculations, just plug it in your calculator, that's what you get.
So then,
It's just the way you did it.
Yeah.
9 goes into 90,
10.
10. A 10 cancels here, right? 5 goes into 25, 5 times. And the answer is supposed to be x. And what was x?
5.
Holy shit. There you go. Okay, so every time we do a problem like this, you could technically make x anything you want it to be, and then work it out and see if it does come out to what you predicted it would come out to be. It should just be that number, whatever you pick. You all heard that kind of thing before, haven't you? Pick a number. Now add your age to that. Now subtract the number of TVs and blah blah, and you end up with the number 2. Amazing. I mean, that's all they do. They make an equation that has a lot of pieces cancel out until you get something, maybe x or 2x. It's double your number. You know, that kind of thing. That kind of explains that. All right. I want to be careful though. Let me see if you guys get this. Just looking at something like this here, it's related to that problem there. I could put whatever I want to in there for x, except the values that make what happen. What can I not have happen in there? What would make it undefined if the what was what? If the bottom was 0, right? So in English, can't I say the bottom can't be 0? Cool? We know that. The bottom cannot be 0. We know that. What's that look like in mathish? What is the bottom in this case?
X squared.
Denominator, which is x squared minus 4x. How do you say can't be in math?
Cannot, like, equal with the sign.
I like it. 0. How do you solve that? We just did a whole section about, and I know it says not equal to, but that works the same way as equals to. You solve it the same way. What do I have to do to this side to start to solve this? Factor it out. That's equal to 0. That's a higher power than 1. I can factor it out. Stay with me now.
Would you just take it? I was going to ask if you take that.
Oh yeah. So the same thing, we actually already did the factorization here, right? So x can't be what? X can't be 0, and x can't be
Negative
4.
4.
How we doing?
That was 7.2 change.
This is actually from 7.1. It's just I remembered that I forgot to talk about it. So when they ask you, the question is going to ask you this kind of thing. Let me take it right out of the book. It's going to say find the values of the variable that make the expression
True.
undefined. So technically it should be 0 and 4, but I mean it makes more sense to me to say x can't be 0, x can't be 4. To me that's still answering the question. You identify those values that you cannot use. You with me?
Sure. That's why we're solving it as if it's like it's equal to 0.
Exactly. Because if we can figure out where it's equal to 0, we just say x can't be those things. If that makes the bottom 0, if 0 and 4 make the bottom 0, then x can't be 0. X can't be 4. Because that would make this undefined. So it's sort of like, here's an easier example. Easier because you don't have to factor. What can x not be there? Negative 7. X can be 0 here, right? I always get the wrong answer from people that say x can't be 0. No, the bottom can't be 0. X could be 0. That would just be 1 over 7. X cannot be negative 7. So when do you have to factor the thing? When the bottom is more complicated. When the bottom has more parts to it. You have to factor it so you can set each part equal to 0. Okay, how we do? So now you see. So the last section in 6 was an explanation of one reason why we need to be able to factor. And now we're using that whole thing to talk about when this is good, when this is actually valid, when it's defined or not defined. Okay. Maybe. So let me see. Let me give you guys a couple of problems to try by yourself. I won't say a thing. And then we'll take a break. and then we'll continue. So try these out. So there's my grammatically incorrect instructions there, but I think that's what we just did. What if? I don't know. Sorry. I would like that one. So call me over if you need some help.